working on the second part to the question given in our first video on curve sketching. Consider g of x equals x squared minus x minus 2 over x plus 1. Use curve sketching methods to draw its graph on the Cartesian plane. We will be using a similar process to that we did with the previous question. First, let us see if we have any discontinuities. Right away, we see that x can't be negative 1 because then our denominator would be 0 and we would have an undefined function. Next, we look at our intercepts. G at 0 is equal to 0 squared minus 0 minus 2 over 0 plus 1, which is equal to negative 2. And so we have a y-intercept of minus 2. To solve for our x-intercept, which gives us 0 equals x squared minus x minus 2. This factors to be x minus 2 times x plus 1, and so we have an x-intercept at x equal 2, and even though if it's the requirements we cannot have an x-intercept at x equal negative 1, since this is our discontinuity. We now consider any vertical asymptotes. Looking at the denominator, we have a vertical asymptote of x equals minus 1. Forgive the error that says x equals 1. We also find our horizontal asymptote by finding the limit. We first cancel out the top and the bottom, and then we find that the limit as x approaches infinity of x minus 2 does not exist, and so we do not have a horizontal asymptote. But this means that we do have a hole at x equals minus 1, since x plus 1 is a factor in both the numerator and the denominator. We now find the y value of our hole, so g of minus 1 is equal to minus 3, and so we have a hole at negative 1, negative 3. We next consider any critical points. Finding the derivative, we get 1, and so we see that there are no critical points, since the derivative is constant, and this goes the same for our second derivative, so we do not have any points of inflection. We now draw our Cartesian plane, keeping in mind all of the different factors that we have determined throughout our process. We first draw our vertical asymptote at x equals minus 1, and then take note of the points that we have, so the hole at minus 1 and minus 3, as well as our y-intercept and our x-intercept. The final thing we do is draw our function. So we see that although the function appears to be linear, it is important to note that there still is a vertical asymptote and a hole. For more information on curve sketching, please refer to our library guide page, and feel free to book an appointment with the Math Drop-In Center if you have any further questions.